I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. I tend to wake up sometime around 6 a.m., 6:30. The first thing I do after I wake up is I take the pen that's on my nightstand and the pad of paper on my nightstand, and I write down the time in which I woke up. The reason for writing down what time I wake up is because I want to know what's called my temperature minimum. I don't care what my actual temperature is. I care when my lowest temperature is, and I know that that lowest temperature is approximately 2 hours before my average wake-up time. The second thing I do after I wake up is to get into forward ambulation, which is just nerd speak for taking a walk. There's a phenomenon whereby when we generate our own forward motion, forward ambulation, visual images pass by us on our eyes, so-called optic flow. Experiencing visual flow has a powerful effect on the nervous system. The effect it has is essentially to quiet or reduce the amount of neural activity in this brain structure called the amygdala. And many of you have probably heard about the amygdala for its role in anxiety and fear and threat detection. And indeed, the amygdala is part of the network in the brain that generates feelings of fear and threat and anxiety. It does a bunch of other things too, but that's one of its primary functions. Forward ambulation, walking or biking or running, and generating optic flow in particular, has this incredible property of lowering activity in the amygdala and thereby reducing levels of anxiety. I want to have a high degree of focus and alertness because I'm soon going to move into a bout of work. So in order to do that, I make sure that the walking is done outdoors. I do it outdoors because I also want sunlight in my eyes. Getting sunlight in your eyes first thing in the morning is absolutely vital to mental and physical health. Even if there's cloud cover, more photons, light information, are coming through that cloud cover than would be coming from a very bright indoor bulb. So getting outside for a 10-minute walk or a 15-minute walk will basically ensure that you're getting adequate stimulation of these neurons in the eye that are called the melanopsin intrinsically photosensitive ganglion cells. These are neurons that convey to the brain that it's daytime and it's time to be alert. And it sets in motion a huge number of biological cascades within every cell and organ of your body, from your liver to your gut to your heart to your brain. Early in the day, we experience a natural and healthy bump in a hormone called cortisol and promotes wakefulness. It actually promotes a healthy immune system, and combine it with the forward ambulation with the walk and the optic flow that I talked about before. And that's what I do each morning to generate a sense of alertness in my body and brain, to generate a sense of calm yet alert. I'm a big believer, based on quality peer-reviewed data, that hydration is essential for mental performance. As many of you know, neurons require ionic flow. What that means is neurons need sodium, they need magnesium, and they need potassium in order to function. We do tend to get dehydrated at night. I try and make sure that I'm hydrated early in the day before I begin any work. So I make myself drink this water with a little bit of sea salt. How much sea salt? If you really want to get detailed, I suppose it's about half a teaspoon. It's not much. At that point, I start craving caffeine, but I don't drink that caffeine yet. I purposefully delay my caffeine intake to 90 minutes to 120 minutes after I wake up. The reason I delay caffeine is because one of the factors that induces a sense of sleepiness is the buildup of adenosine. The buildup of adenosine accumulates the longer we are awake. When you wake up in the morning, your adenosine levels are likely to be very low. However, caffeine is an adenosine blocker. It's actually a competitive antagonist for you aficionados. It sort of parks in the receptor that adenosine normally would park at and prevents adenosine from acting on that receptor. That's why you feel more alert. The reason for delaying caffeine intake 90 minutes to 2 hours after waking is I want to make sure that I don't have a late afternoon or even early afternoon crash from caffeine. One of the best ways to ensure a caffeine crash is to drink a bunch of caffeine, block all those adenosine receptors, and then by early or late afternoon, when that caffeine starts to wear off and gets dislodged from the receptors, a lower level of adenosine is able to create a greater level of sleepiness. Delaying caffeine to 90 minutes to 2 hours optimizes this relationship between adenosine and wakefulness and sleepiness in a way that really provides a nice, consistent arc of energy throughout the day and brings energy down as I'm headed toward sleep and falling asleep. My primary objective early in the day is to get into a mode of being focused yet alert so that I can get work done. I found that the best way for me to achieve that state is through fasting. So I don't eat anything until about 11 a.m. or 12 noon. Fasting increases levels of adrenaline, also called epinephrine, in the brain and body. And when our levels of epinephrine and adrenaline are increased, we learn better, we can focus better. You don't want epinephrine, aka adrenaline, too high. That feels like stress and panic. You get jittery, you can't focus. But in its optimal range, adrenaline really provides a heightened sense of focus and the ability to encode, meaning bring in, and retain, remember information.